Hello everyone and welcome back to Atman Unlimited. We're going to do just one more video on the 1,000 subscriber button. A couple of people wanted to go over the cam for the play button. It's a pretty basic cam, so it shouldn't take too long. And then coming up in the next couple of weeks I got some really big maintenance videos coming up, so that'll be pretty cool. So let's just jump right into Fusion 360 and take a look at how we cammed the 1,000 subscriber play button. So here's the model again for the 1,000 subscriber play button. Now, one thing that I did slightly different with this, and I've never done this before, is I put all of the pieces parts in one file. So there's only one Fusion file that contains everything. I don't know if I'm going to do this again. It kind of clutters up the file and it really blows up the timeline. What I've done in the past on large models like this that have a lot of components to them is I've made a file for each component and then made a file as a top-level assembly and then just assembled each component as a linked file. And that's typically how a lot of drawings are done in industry. You know, I like this method of having everything in one place, but it does tend to get cluttered and the timeline, you know, does tend to explode. So I don't know if I'll do that again. So the other thing that I found is when you're in the cam environment and you're looking at the camfer part, you can't isolate anything, and I don't know why that is. So if you right-click on a part in the modeling environment, you can isolate it. So if you only want to work with one, you know, portion of the assembly, you can. So I find myself jumping back and forth between the model environment and the cam environment to isolate things. So let's start with the 0, and the numbers were pretty complex. So there's a whole bunch of ops. So the first op of the 0 is to face it off and then profile it and then drill and tap this hole. So pretty simple. Now when I did the facing, I actually took my face mill and I gently ramped it in, and then I ran around the perimeter using a contour rather than a true face. And what that did is it put a really nice consistent surface finish all the way around the numbers. So that was the reason for that, rather than just going back and forth with the standard you know, facing toolpath. Then we just did an adaptive clear in the center and then contoured it. We just did a slotting operation ramping down around the OD. Then we spot drilled, chamfered, drilled, and then tapped. So that was all the operations for the 0. Now the number 1 was similar. So that would be this guy here. So face, OD. I had to finish out the radius with a little bit different, smaller tool, and then spot drill, chamfer, drill, and tap. You know, the one sitting right here. Now, I did something a little different than you normally would. So I had to make 3 zeros at once. And rather than run the program 3 different times, what I did is in the setup, I told Fusion under the post-processing tab to use multiple work offsets. And I told it to duplicate 3 work offsets and increment it by 1 each time, starting with work offset 2. So when I did my machine setup, I set up work offset 2, you know, at the bottom corner of the stock, bottom left corner of the stock, and then I just offset Y by the width of the stock, and then I offset it again by the width of the stock. So then it made 3 separate spots on one sheet of material to machine all of the zeros at once. Now the tricky part about this is you have to make sure that your post-processor will handle this. And one thing I found out with my post-processor is I wanted to order it by tool. So if you order it by tool, it will use the face mill and it will face all 3 sets. And then it will switch and use the 3/8 mill to mill the center of all 3 sets. But when I ordered it by tool, the transition from one operation to the next operation didn't have the machine go back to machine home, so it ran the risk of colliding with things on the part. So you have to be very careful of that. If I ordered it by operation, then it worked correctly, and between each work offset the machine would return to home. So ideally it's nice that the machine returns to a machine home in between changing work offsets, just in case your work offsets are at different Z heights. You don't run the risk of the tool smashing into the part as it transitions from one work offset to another. Or if there's an obstruction in the way while it's traversing XY, you don't smash the tool. So you have to be very careful when you do this that your post processor will handle it. Not all of them do. So that's how I made 3 separate parts all at the same time. Now you notice I've got a whole bunch of different operations here, and then I've got yet another set of operations here. So the reason for that is I actually post-processed all 4 of these setups in the same file because I wanted to do all of the 0 operations first and then do the initial operations on the 1, and then this basically is just to cut out and then leave little tabs for the numbers. And I wanted the sheet to stay as rigid as possible during the main machining operations and get the form right. And then as I started cutting all the numbers out, I would lose rigidity in the material, but I didn't care because I wasn't actually touching the finished part with the end mill. So I used a 1/4 inch cutter for this, and it was in a 3/8 inch groove, so I had a little bit of room on each side for clearance. So it would do all of these operations on all 3 parts, then it would come back and do the 1, then it would do all 3 operations on the 3 zeros, and then it would come back and do the 1. So that's how I set up the numbers on the sheet. So then once that was done, now we had the challenge of machining the backside and doing all the backside machining. And this got a little bit tricky. So to do this, you saw in the video where I made a set of soft jaws. So here's the soft jaws that I made. There's one of them, there's 2 of them, and then there's the number. So I took and I imported the drawing of the numbers, and then I just did a project down onto my standard soft jaw to generate the cutouts here. Okay? And then I used this point here on the soft jaw as the origin for the machining operations. So if we go back to CAM, you'll see to machine the soft jaw I put it on the bottom, but to machine the numbers I put it here. I'll show you that. Okay, so these were very simple. Let's turn the numbers off. So these are pretty simple to make. Adaptive clear, contour it, and that's about it. And then do the other side. I had to do the other side just because I wanted it reversed so that when they were flipped over, the zeros would line up. So if you notice, this offset is over here, and then this offset's over here, so it's backwards. See how it flips? So that's the soft jaws. They're pretty easy. Blanking out soft jaws is pretty quick. It takes a couple of minutes to blank out a soft jaw when you use big tools on it. So then, once I had that, I had to do a couple of sketch points. So if you notice here, oh, wait a minute, getting ahead of myself. So on the 0 point is out here in space, kind of in a weird spot, okay? And the reason for that is it's off of the front corner of the soft jaw because the actual number itself doesn't have a good place to put it. It should be on a sketch. So you can see I made some sketch points, and I used that point and some lines, some construction lines, to generate that 0 based off of measurements on the soft jaw. So that's how I referenced, these parts that are completely round and, don't have a single corner on them, so they're kind of hard to index. So by using the soft jaw and then a corner on the soft jaw, I was able to index them, very accurately. And the same thing goes with the number 1. So if we turn on the number 1 and the sketches, you'll see the lines And the number 1 0 point is way the heck out here. So if we look at that, just because if you remember on the soft jaw, the 1 is over here, so then the corner is over here. So these use the same 0 point. It's just that this one's offset to the other side of the soft jaw. So then that will give us the final machining. Now the other one tricky part that we had was getting this hole accurate in the part. And again, I used the soft jaw to kind of hold the number, and it would holding the soft jaw up against the vice jaw and putting it in. I think you saw me do that in the video. That helped me line the part up so I knew where this hole would be located relative to a fixed reference point on the vice jaws. So same thing for the 0. So that's pretty much the numbers. You know, at face value, they looked a little hard to machine, but they weren't that bad. It's just profiling. Okay, so then we had the motor mount. This was a neat little part. Took a lot of setups on it just because of all the different drill holes in it. So here's the motor mount. So motor mount took 3 operations. So first operation, so it was held in, the stock was just held in a device like this. We just ripped the top off, and then we adaptive all the way around it to clear the majority of the stock off. Then we cleared off this ledge. Then we profiled it, and chamfered it. So that was, op 1. And then we had enough material down here that we were holding on to so we could get all the way to the very bottom of it. So that generated the basic form. And then for op 2, we flipped it over like this and then put it in the vise like this, and I put a little piece of scrap underneath it so that I could drill through it, okay? And then I removed the OD first just because I was afraid the face mill would grab it because the part's so small. And then I ripped off the rest of the top here once I had the ledge decreased significantly. Chamfer it, spot it, drill it, done. Okay, so that's op 2. And then op 3 is simply just putting in these holes and countersinks. So drill it, countersink it, or spot it and countersink it, and then drill it. Alright, so that was the motor mount. Nice little simple part. So then, let's just talk about the button real quick before we get into the base. So the button you saw, I roughed it out on the lathe, and I did most of the work on the lathe for the button. So there's the button. So I made a round disc, and then I turned it down and made this thread, and then I used a die to put this external thread on it. And then once I had that, I actually used this thread and put it in I just took a piece of aluminum and drilled a small hole in it, and then used this thread to actually hold the part down. And then I just took the same exact mill, the 3/8 mill, and I just ripped the top off of it real quick, and then just contoured it. So the button was real easy to make. It was real quick to make. Pre-making this part on the lathe definitely was the way to go, even though my lathe isn't that great. The small parts it's okay with. Okay, so now the big guy, the base. Okay. So here is the base. And the base is also split up into 3 operations. Basically, I roughed the face and then I finished the face. And I used the different face mill to finish it just because the inserts in my 1.5" face mill leave a little bit better quality finish than the inserts in my 2" face mill. Better finish, less sanding. And I'm all about less sanding. It took a little bit longer to run, but it saved me a lot more time in sanding. So that was good. After I finished the face, we just ripped off the OD Then we finished the OD. Then we spotted where we wanted the play button to be. We drilled this hole all the way through. And then we used a really tiny 1/16 of an inch end mill to machine this pocket out using an adaptive. And then we contoured it. I didn't come back and finish this bottom here because it's never going to be seen. So not a big deal. We just contoured the outside to bring it to final dimensions. Now there's 2/1000ths of an inch clearance between the button and the outside perimeter of the base, and the reason for that is there's a little bit of capped on tape that insulates the button from the base, so the button's a little bit smaller than this hole. After that we switched over. I just used a little tiny 1/8 inch chamfer mill that's ground to a point to do the actual engraving. So I use the 3D adaptive, or the 3D toolpath of Project, and then you just select all of the sketch contours, and then it basically just traces the outline. Then I took it out and flipped it over, and we moved on to Op 20 to machine all of the stuff in the back. So this, we just roughly faced it, because again it's the back. Then we took off the rest of the OD from the back. We did an adaptive for roughing out all this material in the middle with a 3/4 inch mill. Then we just cleared out this little bit. Then we ran around it, finished the OD, finished the center on the bottom, just clean it up a little bit, finished the wall, finished off these parts, and then I switched to a 3/8 inch end mill to finish all these corners. I just let it run all the way around the part just because it was easier to cam, because these radiuses needed to be smaller. The 3/4 inch end mill left too big of a radius for the circuit board to fit. Then we spot a whole bunch of holes, spot the bearings, switch to all the 440 holes, tap them, drill out the bearings, then we're going to ream them so that we get a nice hole for a press fit, so the bushings are press fit into here. And then we just do a little bit of chamfering to clean up all the edges. So that is Op 20. Now the reason why I did this in 3 ops and not 2 is this decorative radius on here. So in the first op I only finished down to about this level, and then on this op I finished this face here so that it left, if there was any little bit of misalignment, the gap would be here. And then in the next operation I flipped it back over like so, and then we did a roughing pass with a 3D adaptive to get rid of the majority of the material. And then I used a 3/4 inch ball mill, and this is a 0.375 radius, okay? And then I just profiled with the ball mill, and that left a really nice finish on it. And then I came back with a chamfer and I did a real deep chamfer in here, and then once I wet sanded it, it knocked off these corners and it came out really nice. It almost looks like, you know, a wood router bit would make. So that came out really nice, and it was all about just trying to hold this. So while I was doing these operations, I could hold it down here on this face here. When I was doing Op 2, I could hold it here on this face here and still machine this face. So it was just convenient and an easy way to hold it, to split it up into 3 operations. So that's basically it. If you want, we can simulate this. So we can select all 3 ops and do a simulation. We can turn off the tool paths, turn on the stock. Go back to the beginning. So you see it takes off the top, finishes it, roughs it, profiles it, then we flip over. It's kind of neat watching it in high speed. And we just clean it up a little bit. contour it, drill it, tap it, chamfer it, and we flip it over again. Then we're going to rough it out. And then ball it, chamfer it, and done. Then if we turn the model off, see a nice simulation of it. There's the play button pocket. There's all the engravings on it. Profile. And all the insides. So that's so there's a quick rundown of the cam for the play button. So I hope you enjoyed this video. Didn't want to go into too great a detail and bore everybody to death on this one. So if you have any questions, please feel free to comment below or send me an email. We've got some maintenance videos coming up shortly that we'll finish up. And thanks for watching, and we'll see you on the next one.